Hello and welcome to one of the problems for the Chapter 10 homework, or the Chapter 12 homework rather. A uniform 50-kilogram scaffold of length 7.0 meters is supported by two light cables as shown below. A 71-kilogram painter stands 1.0 meters from the left end of the scaffold and his paint bucket is 1.5 meters from the right end. If the tension of the left cable is twice that the tension in the right cable, find the tensions in the cables and the mass of the bucket. So we have two unknowns here, which means that we're going to end up needing two equations. And the thing that about this is that it's going to be a statics problem, but it's going to be a more complex statics problem that we've seen before, where in addition to having the conception that sum of F equals zero, you also have the sum of all torques equaling to zero. So in order to do that, you have to have knowledge of both all the forces that are acting on it and all of the distances away from some pivot point that you can choose. You can choose any pivot point to be your 0 point, but in our case, I am going to choose this left-hand pivot point here, this point where the tension of the rope is, to be our pivot point. So this is equal to 2t right, by the way. So that's so we technically have three unknowns: the tension in the left cable, the tension in the right cable, and the weight of the bucket. But we only need these two equations that the sum of all forces are equal to zero, which is just going to be a one-dimensional problem because everything's either up or down, and the sum of all torques is equal to zero, which is going to also be a one-dimensional problem. And then the relationship between TL and TR is that TL is 2TR. Therefore, you're going to have all that you need to do to find both the tensions and the mass of the bucket. So this is going to be sum of Fy is equal to 2TR up minus the weight of the person down minus the weight of the scaffold down minus the weight of the bucket down plus TR up. So all of the weights are pulling down. They're being pulled down by gravity. So the scaffold, the person, and the bucket are all having an effect on the uh are all having an effect on the scaffold, which is to pull them down, and then the tensions are going to be pulling up. The torque, however, is going to be compared to 0 times t left minus 1.0 meter times the weight of the person minus 3.5 meters times the weight of the scaffold, because that is the distance between the center of mass and the start of the scaffold. It's going to be 3.5 meters. Therefore, that's going to be where the force is acting on for the weight of the scaffold minus 6.0 times the weight of the bucket plus 7.0 times the tension of the right scaffold. So all of these are all of the weights again are going to be negative because they're going to be causing a clockwise rotation. Therefore, they're going to have a negative torque. Whereas the tensions are going to be positive as they're going to be causing a counterclockwise or at the very least zero rotation. Or yeah, counterclockwise or zero rotation, which means that they're either zero or positive. So the only positive torque that you have is going to be the 7.0 times TR, 7.0 meters times the tension in the right one. So 7.0 TR is going to be equal to 1.0 weight of the person plus 3.5 weight of the scaffold plus 6.0 weight of the bucket. But that's not as convenient to deal with. As you can tell, we're going to have to divide through and then solve for all of these in terms of, as you can tell, if we use this equation to solve for our TR, we're going to have to divide everything through and have fractional values of all of these values. So instead, I am going to focus first on this equation where 2TR plus TR is equal to all of the weights added up. Weight of the person plus weight of the scaffold plus weight of the bucket. So 3TR, or 3 tension in the right, minus weight of the bucket, or 1 minus weight of the person minus the weight of the scaffold is equal to the weight of the bucket. You can plug that in over here and find that 1.0 weight person plus 3.5 weight scaffold plus 6.0 times 3 TR minus weight person minus weight scaffold is equal to 7.0 TR, or 1.0 minus 6.0 weight person plus 3.5 minus 6.5, or 6.0 weight scaffold plus 18.0 tension on the right is equal to 17.0 tension in the right. So this is going to end up being negative 5.0 weight person minus 2.5 weight of the scaffold plus 11.0 tension of the right is equal to 0. Just adding up everything on both sides. Therefore, 11.0 tension to the right is equal to 2.5 times the weight of the scaffold plus 5.0 times the weight of the person. So tension in the right is equal to 2.5 weight of the scaffold plus 5.0 weight of the person divided by 11.0. So you can just plug in numbers there. I'm not very big on plugging in numbers when you can just leave it as algebraic notation. So I'm just going to leave it as algebraic notation, but we know what the weight of the scaffold is and we know what the weight of the person is because weight is equal to m times g. So the weight of the scaffold is going to be the mass of the scaffold times gravitational acceleration, 9.8 meters per second squared. And the weight of the person is going to be the mass of the person times gravitational acceleration. So we take this, we plug it back in over here, and we find that 2.5 times 3, 7.5 weight of the scaffold minus 15.0 weight of the per or fifth plus 15.0 weight of the person over 11 minus weight of the person minus weight of the scaffold is equal to the weight of the bucket, which is going to be 7.5 weight of the scaffold plus 15.0 weight of the person minus 11 weight of the person minus weight of the scaffold over 11, or 11 minus 11 weight of the scaffold over 11 is equal to the weight of the bucket. And then putting that through, you have 4.0 weight of the scaffold minus, what is 11 minus 7.5? That is going to be 3.5. 3.5 weight of the person over 11 is going to be equal to the weight of the bucket, which is going to be the mass of the bucket times G. So using this, we found TR, we found weight of the bucket, and we can also find the TL being 2TR, given this equation. And that should be all that you need to do in order to solve for this. Thank you very much, and I'll see you in a bit.